Pierpaolo Andriani, so he's a physicist gone wrong somewhere in his career, so he started working on innovation and complexity. That's what now he teaches at Kedge Business School, who is one of our partners. He also forges and juggles with concepts, and I think what he's been seeing and hearing around Fab Labs and digital fabrication has actually inspired him and resonates with some of his research, so I will give him the floor.
Thank you for the invitation. It's first time for me to
Go ahead.
Well, first time for me to be in a maker community. I'd read a lot about it, but first time I actually seen a 3D printer. So I'm going to put my watch here because I'm Italian, so I've got a bad reputation for timekeeping, right? So I'll try to stick to my time. Right. Okay, so I'm going to talk about something a bit strange, maker's design and exaptation. So let me start with a rhetorical question. What is a horse? Is that a horse? I cannot. Well, I mean, we agree that that's the foot of a horse. If we move to that, is that a horse? That's an embryo of a horse, 10 days old. Some people say it's not yet a horse, but all the information for a horse is there. So I would claim that that is a horse as much as that one. But then the big question is that a horse? That's the genome of a horse, the set of the DNA of a horse. All the information to make a horse is there, including the information for the machinery that reads the DNA, which is coded in the DNA itself. So in my opinion, that is a horse as much as that one. And then the question is, okay, we know that evolution proceeds on a double level, the level of genetics and the level of the physical organism. But if we move to technology, is the situation different or not? And so another rhetorical question, is that a chair? Well, of course, that's a foot of a chair. But is that a chair, that one? Well, that's a schematic of a chair which doesn't contain information to actually make a chair or the painting next to it. And then the big question is that a chair? Well, all the information to make a chair is there, including the material, the color, and so on. So I would claim that actually is a chair. And the conclusion is that we have, thanks to the makers and software and to the concept of information, the consequence is that we have biologized technology. Technology, like biology, proceeds on a double level of the information set, which is read by a machinery, which then forms a physical object which interacts with its environment in order to deliver product of a service of an organism. And there's no fundamental distinction between technology from this point of view and biology. What are the consequences? The consequences for let's say, the people who are interested in technology or in artificial forms is that we have gone from a form like that for all the history of our species, so form as an information embedded in atoms, to a form which now is a form of bits, which includes the information, all the information to make the physical form, and the form as atoms. And both of them really they represent a structure in atoms or a structure in bits, and both of them are executable. They are programs to do things. But there's a crucial distinction between the program that the bits can do and the program that the physical object can do. Three consequences follow. First, the form as atoms has become an instantiation, a consequence of something living in a world, in an abstract world of information. It used to be the opposite. Second, like in biology, now evolution, or innovation if you prefer, proceeds on the double level of information, as information of the chair, and information as information of the physical objects. And that makes innovation faster and more robust. But third, and most importantly for the consequences on design, is that for the first time in history, we can actually separate design from manufacturing. And this, in my opinion, but not only my opinion, has very important consequences. And let's have a look at the consequences first. But first, what relations do we have between bits and atoms? Do we have operators acting on two different types of forms? And yes, we have the operators. We have seen them today. The first operator translating bits into atoms is actually a 3D printer, and that's fine. But the second operator, which we haven't mentioned that much today, is actually 3D scanners converting atoms into bits. And that forms a cycle that, for want of a better word, I've defined as the maker-design cycle. This maker-design cycle becomes a self-sustaining cycle. The more bits we have, the more forms we can create, and the more forms we can create in atoms, the more bits we can create. As all cycles, it becomes self-sustaining. And we know that self-sustaining cycles have given rise to what has been described today as the long tail. It used to be that we had only the head, the mass manufacturing products, and now we have the tail. So we have had an explosion of forms. But then the consequence is this the explosion of form self-limiting? What is limiting the number of forms that we have in the universe? So what does it mean for design? I think that the limit of forms is actually in the concept of function. If we go back to the idea that forms as bits and forms as functions are basically executable, the forms as bits execute information in order to turn bits into atoms. The form as atoms is an executable that delivers a function, a utility. But the differences between the two is that the form as bits univocally identifies the atoms, whereas the form as atoms is a predisposition which is controlled by the user. And that's a fundamental consequence, in my opinion, for the community of makers. So the form as atoms is only a scaffolding over which the users can build functions. And then the question comes, where do functions come from? Who invents functions? And if we go back to the origin of modern theory of design, Alexander, an architect, he basically said very famously that the process of inventing physical forms is basically in response to a function. But then the same question remains, where do the functions come from? Some people say that functions come from science. So scientists discover scientific phenomena, and then they are linked to needs in order to deliver functions. If we look at reality technology most often comes before science, so that's not the explanation. And function is a problem, because if you think about it, we have a vocabulary from engine. Engineers control engines. We have a vocabulary for manufacturing, because manufacturers control manufacturing. Craft people control craft. Designers control design. But who controls functions? Functioners? We don't even have the word for it. And I think the reason why we don't have a word for functioners is because functions themselves, they come from forms. They come from objects. And the process from which functions are discovered through forms is what we call in biology exaptation. And exaptation, let me give you some examples. The first microwave oven was never invented. It was a piece of a radar called a magnetron, which was discovered by chance to actually cook food. It was the first time in the history of humankind that cooking was done without a source of heat, right? And that's actually the first microwave oven, 1947. And you may know about the solar bottle. In the slums of emerging countries, there's lots of solar light, but there's no often light within houses because Often windows are expensive. So somebody had an idea. I take a plastic bottle, I put water inside, I stick through a roof, and that delivers a perfect warm, diffracted light because of the presence of water. And it works extremely well. And you know this object, you know, the cigar lighter in cigarettes, and that has been accepted by using, so a new function has been discovered because the object was there, and then has given rise to all sorts of innovation. And we can move on. The first synthetic drug was actually a dye used in the textile industry. The first antidepressant, if you go to that magazine, 1952, you'll see the story of the very successful anti-tuberculosis drugs, which made patients euphoric. Those are severely ill people that were dancing. Because that drug, conceived for tuberculosis, was also an antidepressant. It made patients euphoric. So antidepressants were discovered because anti-tuberculosis was set there. And this is the principle that Stephen Jay Gould, the American paleontologist, called the tire to sandals. So tires are there, they're a waste, and they can be recycled if you go to that website in order to make that. But today we have seen plenty of that here. You know, the drums from gas cans and the photos. This is a chocolate contraption to distribute drugs to children in hospitals and recycling of waste. The point I'm making here is that we don't invent functions. They are already existing, in many cases, within the forms that we have around us. Then the problem is, how do we discover the functions hidden or pre-adapted within forms? And this is where we go back to our cycle of makers. Separating design from production has paradoxically created the condition for putting the two under the same roof of our metaphorical garage. And all of those activities now are controlled by the same entity, the user. But even more, by separating design and production, and by creating technologies that make simple for users to design and produce, you know, the 3D scanners and the 3D printers and the other technologies, that with time will become invisible. They will become like oxygen. We depend on it, but we don't notice it. Then what will happen, or what's going to happen already, is that designer, producer, and user will be under the same roof, controlling the entire phase. And that means that we bring back into the process of designing, producing, and using context. And context is what leads to the discovery of hidden functions within existing forms. So what I'm basically saying is that the cycle of design, production, and use is what creates the opportunity for radical innovations or incremental innovations, and this is a specific characteristics of the maker movement, which is probably exists, at least in a mass market industrialized society, for the first time in history. So the makers movement is not only, though, to a certain extent, you know, the limited version of high-tech control by large enterprises. It's probably going to become the core of new functions discovered by the discovery, if you want, of pre-adapted functions within forms. And the more we multiply forms, the more we create the opportunities of discovering further functions within forms. And if you look at the entire cycle, then you have that traditional design is actually the process of translating existing functions into forms. Now, the two types of forms. Production, at least in the makers community, can become really the translation of bits into forms. But more interestingly, what makers can do better than other organizational forms is they can accept forms into new functions, which will then reactivate the whole process. So I'm introducing for the sake of a better world, I called it exaptive design. I'm introducing the idea that it has already always existed in design, which is designers, when joined with production facilities, which then become invisible because technology takes care of the complexity, can discover new functions that activate the new cycle. And that's really the conclusion of my talk. If you want, we are going toward the experience economy, because makers have a fuller experience, and of course, that's not a bone. It's probably one of the first exaptations on Earth. Thank you.
Merci.
14 minutes.
C'est très bien. Il y avait le temps. Je peux parler en français pour les questions?
Oui, oui, oui.
Voilà, comme ces étudiants. Bon, merci pour cette espèce de remise en perspective un peu de l'ensemble, et peut-être comme cette remise en perspective de quelque chose qu'on connaît bien dans le monde numérique aussi, qui est la vertu du détournement, alors qu'on connaît bien en fait dans toute une série de domaines, mais en fait ici en disant c'est peut-être la base d'une reconstitution d'un circuit. Moi j'aurais un peu deux questions en fait qui venaient aussi un peu de certaines des discussions. C'est du coup, quand cette fois-ci si je suis designer ou si je suis industriel, est-ce qu'il y a des manières d'essayer de changer ma manière de travailler pour rendre plus facile les détournements ou les processus d'exaptation?
The ways have been, in a way, already presented here, and upstairs there's plenty of people who have already been doing that. From a theoretical point of view, the organizational challenge is the multiplication of contexts to which products, services are exposed. So we need a network, or we need a recombinant network in order to, as if you want in the Silicon Valleys of the world, in order to re-expose or expose existing forms to new contexts. Having the experience then of the production and the design of those forms led to a better discovery or higher probability of discovery of underlying functions. And I claim, but it's not me who claims that main important functions, so the majority of important functions have been discovered via accepting existing forms. And this is why innovations come from cities. Predominantly, 90+% of innovations come from cities, because that's where you find recombinant clusters. So the challenge within organizations is to create recombinant clusters.
Okay, and are there actual functions, or maybe let's call them platforms, that need to appear so that these kinds of processes of loops become more efficient? Are there new economic functions also that could emerge?
Well, the issue of platforms is the issue of ecosystems. I mean, every platform generates an ecosystem, but we don't need ecosystems to generate. I mean, we can have ecosystems without platforms. The advantage of platforms is that they become an architecture or scaffolding onto which to build. And that's what the open source communities, going to Apple, going to Google, have been doing. So they create basically the APIs, the application protocol interfaces, for the external intelligence to join in order to build a platform where we have multiple type of transactions in the market. It's not traditional supply chain with one function only going one direction, money going the other direction. It's multiple roles, multiple types of transactions, and so on. And what's the consequence? It's always the same. We create recombinant clusters, and we discover new functions that other organizational forms struggle to discover, at least compared to a recombinant cluster. And the makers have an additional advantage, because there the three roles, as I said, of designer, producer, end user are joined together.
So new missions for business schools, find out how to build organizations that are friendly to those recombinant processes.
Yes.
Merci beaucoup.